Okay, what we're looking at this time is a lash up of a few boards. I've got a CANGIZMO, which can test CBUS board's responses to messages on the bus, just tests an ACK. I've got a CAN USB at the top there. I've got a board that's just got a pile of connectors on it to let me join everything together, and a power switch connected to a board that until about an hour ago was a programming board for PIC 25K80s, but I've just added the components to turn it into a board suitable to run CANCOMPUTE. It's unusual in its configuration, that board, because it's got a LM317 as the regulator. That was done because when it was a programming board, it gave me better access to the top of the PIC to get a screwdriver in there and get it out. And I'm not going to change that. It works this way, so, well, it should work this way. The board has not been tested yet. The PIC's just been through programming that I did a previous YouTube video on, and the sound on that video was pretty crappy because I didn't realize that the lapel mic wasn't working. Hopefully this one's better. The switch on the bottom left of the screen there is just an on-off switch for power to the module that I want to test. Right now nothing's happening, and I'll just show you a couple of things about CANGIZMO while we're here because it's pretty simple. Logically, our bus is just a CAN USB, a CANGIZMO, and a CANCOMPUTE. Given the CANCOMPUTE's turned off, the bus isn't even that much right now. The CANGIZMO over here, I'll get a pen. Yeah. The jumper here is set for don't terminate, and the jumper over here, well, the jumper switch over here is configured for monitor. So it's listening for messages on the bus, and there aren't any. So if I turn on the test mode to generate messages looking for ACKs, what I see now is it transmits and I get an error. That's what the orange light's telling me. And that's because the bus isn't terminated. If I now terminate the bus, we can see that we're getting ACKs successfully back. So the CANGIZMO is successfully talking to the CAN USB. Disconcertingly, on the screen, there's a bit of a delay before the flash, so I'm going to try just to look at the module. Now I'm going to change the mode of that module again and hit my reset button, and away she goes. She's back in monitor mode. Now, there had been trouble programming CANCOMPUTEs and on the board when the crystal's on there, and I've just done a video about programming them on a board that doesn't have a crystal on there and shown that that works successfully. I have seen a glitch in doing this stuff, so I thought, right, I'm going to do a control test from way to go and see that everything works the way it should. So what we're going to do is we're going to power this up. We're going to add it into a configuration using FCU. We're going to put a few, we'll have a look at a configuration, a simple configuration for CANCOMPUTE. We'll load the events into CANCOMPUTE and do the rest of the configuration and just see what messages I get, because it's one of those things where you think you got it right, but it doesn't play right, and you go back and you do it again and it works. So I just wanted to go through this from where to go and see what happened. So when I flick the switch, the CANCOMPUTE will power up, and hopefully there won't be smoke and there will be a green light. In fact, we've got all the lights you would expect. The blue here is a power LED for the board. The orange here is a LED that indicates the CANCOMPUTE's going through its loop processing rules, of which there are none right now. And the green indicates that the board is in slim mode. So now I'll share an FCU screen and we'll add the little guy to FCU. And share screen, screen 1. Okay. So now you can see a configuration that I've done a couple of things to. You can see all the ACKs that came from the CANGIZMO. I'll just clear the messages. I'll turn the gizmo on again in monitor mode and you'll see the axe come up. There they go. And I'll turn it off and reset it and clear the messages. Now, this is a simple little configuration where there's two software nodes been created. One's got the address 80, and we'll see why in a minute. And one's got the address 0, as is usual. In the first software node, I've got 3 test events: test in 1, test in 2, test in 3. And they're set at numbers that match the configuration we're going to look at in a minute. The outputs, and CANCOMPUTE doesn't have to only treat events as inputs. It can output the same events if it needs to. But in this case, the test is simple and it's got events going in and events coming out. Similarly, I've got 3 test events in here with those event numbers. Now we're going to have a look at the configuration file. And if I can just find where I put that. Okay, so here's the config file. And what it does first is defines a few events that this configuration is going to use. So we've got the 3 in events there, and I've said here I'm going to use node 80 for testing my outputs, and that corresponds with the node number I gave it in FCU. The outputs could be short events, they could be events, they could be long events with any number. It is a bit of a wolf in sheep's clothing. The CANCOMPUTE can send events from basically saying they're coming from any node you like. So what I've said here is test out 1 is node number 80, event 3001. Event 2 is node number 2, event 3002, and then I said the third output is 80, 3003. We'll come back and look at the rules in a minute. I just want to go back to the config, because now what we're going to do is add this node to FCU. And Greg's made a mistake when he converted this board and didn't put a switch on it. So I'll just pause this video for a sec and get some stuff that I can. Sorry about that. As is always the way when you want to do something in a hurry, the little bugger didn't want to go in first go and I had to muck around to get it in. Now it's in. So let's go back to where we were. We're going to add this node to Phlegm, to the Phlegm config. And the switch is here. 1, 2, 3, 4, 5, 6, 7. Yeah. Got a flashing yellow light. Got a CANCOMPUTE. Off it up. Node number 700. Yeah, well, that's because that's the next number I told it to use for this configuration. And I'm going to call this something ridiculously simple, which is CANCOMP1. Okay. Now, the sequence for doing a config is pretty simple. Read properties. Yep, you can see all the good stuff about it. It's PIC 25K80. You can see that it's a 2A beta 4 firmware. And we'll close that. Now, important we read the NVs, because what we're going to do is replace the NVs all at once later. The board has lots of NVs, because what it does is when it new compiler configuration, it turns your rules in your configuration into node variables to do the work. So you can see a big pile of node variables here with not a very interesting number. But the thing is, right now we've got what we need in the configuration. So I'm going to save that configuration and I'm going to exit. And now let's have a look at this config. What it says is when the state of test1 in is on, then send test1 out. Well, it says when that changes to on, send test1 out as an on event. And otherwise send an off event for that when it changes, when test1 in goes to low. So it's a transition from when the event was on, and then it sees, hey, now this event has gone off. Then it will send the off test out one. So it's not really a if then else. It's a When this happens, when it goes from off to on, it does the first bit, which is to send the on message. And when it's been on and it goes to an off state, then you get the part that's in the then clause. In a CANCOMPUTE, that can be a sequence, but I haven't got that sort of stuff in this simple demonstration. The second one is a demonstration of a compound rule. So it's got, if the state of test 1 in 2 is on and the state of test in 1 is on, then send test out 2. So they've both got to be on for it to happen. When that condition becomes true, because I change one of these two back to false, back to off, then I'll get this then clause executed and I'll get an off event for test out 2. That's what it says on the tin. Received is a bit different. Received is, you need a time in receives that are greater than 0. 0 means no limit here, and it'll keep that knowledge of the state forever when you use the state condition. When you use received, it just says, okay, I need to have received this within this amount of time for this rule to become true. After that amount of time, it forgets knowledge of it, and it should, if I send another on to it, it should send another test out 3. So let's have a look at how we compile these rules. I'll go to here. This is a simple directory that has the 2 configuration tools for the CANCOMPUTE in there. There's the compute v5.1 jar file, which is Ian's compiler, and there's a GUI, and I'm sorry I can't remember the name of the man who did that. It's probably in the about. We'll have a look in there in a minute. And sorry, the CANCOMPUTE GUI is the code to do that work. This is just a simple docx. It has Greg's knowledge of how to configure this thing. And this is a small bat file. It'll just edit with Notepad++ to show you what's in there. It does very little. Turns echo on, make sure drive C is selected, changes directory to where I put the tools, and does a Java with a class path of the directory I'm in to run compute GUI. %1% didn't do anything. It didn't open the file using that as an argument. So I'm going to delete that and I'll save that anyhow. Okay, save. Now, what I'll do is I'll close that because we don't need to know about what that does anymore. Here's the CANCOMPUTE rules. We know what they do. And what we're going to do now is to run the GUI. And if we go back there and we do that just by double clicking it. Yep, here she comes. Now, what I do now is I load the file, gptest.txt, open. On this side, I can edit this and change it and save it if I like. Up here, I can change the, there, Duncan Greenwood wrote it. Up here, I can change the output type to XML or text to the 2 that I understand what to do with. The rest of them I don't know what to do with. But the 2 that matter are text and XML. If I run the compiler, what it shows me is a few things. It shows me what each event is I need to define in the CANCOMPUTE and what I need to give them as EV1. So it tells me to add the event 0 2001 with the EV value of 1, EV1 value of 1. And it says the same thing for each of the events here. That stuff, because this test is simple, is really easy to know what's going on. But you want that piece to know which events you need to set. And you can see you saw earlier that I had already set those events in the software node just by doing learns to get them there. But one of the ways you can get all these node variables into the CANCOMPUTE is to go into generic mode and enter each of these numbers in the boxes in the basically the windows for each node variable. If you make a mistake, it's not going to work. So there is an easier way. It's a little bit, oh gee, I'm going to do something scary, but it's actually very, very simple. If I do the output as XML and run it, I get the same stuff here, but right down here I get all of the node variables. So I'll make this window as big as it goes. And there's not a lot because it's a simple set of rules. And I'm going to copy that line. That's all that matters right now. Now, I'll go back to CBUS. I thought I closed that. It opened that config because it's the only config in the area, that's why. So you can see the node variables here are big and crazy. And we don't want big and crazy. We want the node values that we mean to have there. I shouldn't have opened this. But you can see this is a live demo, so let's do a live mistake. Close that. I didn't change anything. I'll say yes anyhow. Let me go to the config directory for my configs for FCU. I cleared it out here while I'm doing this test because there's 100 odd test configs I've got floating around. I put them in a whole directory. But if I edit this file with Notepad++, what we see is the usual stuff at the top that describes the different module types that FCU always puts in there. Down the bottom is my CANCOMP1. And if I had a lot of modules in here, I just would have searched for CANCOMP1 until I found one that said, hey, here I am, and I'm node number 700, and I'm this module. You can see the node variables here, and that's the piece we need to replace. So what I'm going to do is just put a new line in here and stick my node variables in and just make it pretty. Then I'll delete this line and I'll save that file. Now, what I'm going to do now is go back to CBUS, back to FCU. And you can see FCU, when it read its config, it's got the node variables that we edited in there. The module doesn't because we haven't written the node variables back to the CANCOMPUTE. There's one thing that you can see here. I've set trace all messages on. You need to set trace all messages on so you get a view of whether the CANCOMPUTE is happy with what you gave it. Now remember that normally I would have done the compile, then I would have dragged and dropped the events on, and now I just realized I still need to do that. So let's go back one step. Those node variables aren't written to the module yet. But what I'm going to do is I'm going to go here and drag each of these test events onto CANCOMPUTE. And because of the way I numbered them, it's nice and easy. That's the input events. Now the outputs were 4, 5, 6. Okay, so the events are there ready. The module has the events stored, but it doesn't have the NV variables we need for the rule set. The reason we had to read the NVs earlier was so that FCU had node variables in there, so when we came back we could write them back. So now what we're going to do is go to CANCOMPUTE, node, write NVs. So you see it write all the NVs, but you also see this code come back. I didn't open the instructions for CANCOMPUTE to show what that means. I'll actually open my Word document because I'm pretty sure I stuck it in there. Let's see. I could embarrass myself here by having not put that information in here, but let's find out. And Word opened it on the wrong screen, so I'll just make it a little bit smaller and drag it across. We'll have a look and see what I put in here. Blah, 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 everything I've told you. No, it doesn't have how to interpret the return code that comes back in an ACTAT message. But the main thing is ACTAT comes back. Let me see if I can remember this. ACTAT comes back with 00 if there's no error in the configuration information you gave it. It comes back with 1C for how many bytes there are in the number of NVs that there are that are going to do any work. This number here, the 03, that, yeah, I do remember. That's the number of 1C is the number of those. 03 is the number of rules. And 05 is the number of expressions. And the last one escapes me right now. But what it means is it loaded those rules quite fine. So let's go over here and see what happens when we start turning some events on. Let's do an on event for test N1. Actually, we'll clear messages first. Event on. So our first rule says when you get this as an on, send me, when it goes from off to on, then send me out this output message as I defined it. If I turn that rule off, then it goes away. Now I'm going to turn the second one on. I get nothing out because no rule does anything based on test in 2 changing on its own. But if I change test in 1 as well to on, well, what the first rule says, send out a test out 1 when test in 1 goes to on. The second rule said, when the state of test in 1 is on and the state of test in 2 is on, send test out 2. So you can see that's changed. Now if I change test out 2 to off, I get an off for test out 2. Sorry, test in 2 got turned off, so I got an out for test out 2 because that AND condition is no longer satisfied. Now I'm going to do a test of the last rule that I have. I'm going to turn this one on. And I sent it a message that said, hey, this one's on. If I sent it an off, I get nothing coming back. If I send it another on, I get another message coming out. If I send it another on, I get another one coming out. So this gives me a way to ignore off messages and generate an on event if I wanted an on only coming out of some switch somewhere. There are some problems I've been having trying to get some switches to do just that. So it just demonstrates how you can fiddle with the rules. Now, CANCOMPUTE is powerful as crazy, and you can start to do some hoopy things when you're doing route setting. Hey, if this event comes on and this event's on and this event's on, then guess what? I've met the conditions for this route, so go set all the signals for that route. You can do feedback to say, hey, there's a train in one of those blocks, so don't set the route. You can do lots of cool things. If I understood interlocking and route setting better, I probably would have a couple of rules in there to show you. Right now, the rules are at the limit of my understanding, and so where I'm going next is to try and find out more about NX panels and interlocking. I know how to get the feedback events back from the various modules and using train-on-track detectors and that sort of stuff. So what I've showed you is I've figured out some bits, but I'm far from knowing all I need to know about this thing. And you saw it warts and all with the mistakes I made. Now, hopefully FCU will smile upon me and save this happily, and it did. So the problems I've had previously look like they were all down to me doing something wrong, or I just got lucky, but I suspect it was me doing something wrong previously. You've seen the CANGIZMO sitting in there. I'll stop the share and show you one more thing. If I turn the gizmo to generate mode again and I hit the switch, you can see each time the gizmo sends out a request for an ACK, there's a green light flashing on the CANCOMPUTE to indicate traffic. Like the CAN-MIO boards, whenever there's a message on the bus, it flashes the green. It doesn't necessarily mean that it's a message for that board, though it is encoded on some modules to do that. It flashes longer if I remember rightly, but I'm not certain. Okay, I don't know if there's anything else to show you. I think that's pretty much it. And we can see that my CANGIZMO and my CANCOMPUTE are working the way they should. The board that's built on is a CAN-MIO Rev B board. It wasn't going to get used for anything other than anything at all when it got superseded by other boards. Then I used it for a programming board because it was suitable for that. Then when I replaced that, I turned it into a board to run CANCOMPUTE. So a bit of repurposing going on there. And my dog's going off outside, which might mean the missus is home. I'm not sure. 2 YouTube videos in one day. And if you've got questions, guys, I'll have a look in the comments for a few days to see if there's anything there, and we'll see what happens. I'll exit this, and that should be it. And Zoom, where are my controls? I'll close the meeting. By the way, I'm using Zoom with an iPhone as my camera, using a bit of software, and having a meeting with myself. There you go. A bit lonely, but it works. This is just the last thing I'd say. The little switch on that cable has been kind of useful when I offer up boards I want to play with and not be making and breaking the bus, or making and breaking, well, it will still make and break the bus, but it doesn't make and break power to the board as I plug it in. It's just switched on once. That's it. I hope this is useful for some folk. That's what I do them for. I did this one partly as a diagnostic to see if there was a problem in the way CANCOMPUTE works. I did not see the problems I'd had previously. That blue LED's very bright. Yeah, it's interesting how it's not super bright when I look at it by naked eye, but it's super bright there. In fact, I remember using this board once before, and it's got a 47K resistor on there, and I ended up having to put a 47? No, 4.7K. I ended up having to put a 15K on there to tame it down for another video. Some LEDs take really big resistors to tame them. That's it, guys. Thanks. Bye.